All right, guys, we're on the backside of Unit 3, Day 9 notes. And up at the top, it's talking about absolute maximum and minimum values of a graph and relative maximum and minimum points on a graph. And so we have to know the difference. Okay, so absolute max and min values of a graph, these are the highest and lowest because they're maximum, which is high, minimum is low. These are y values as you read the graph bottom to top. Written as the numeric y value. So we usually don't state the whole coordinate of an absolute maximum minimum, just the absolute highest y value and the absolute lowest y value. But you have to be careful. If there are arrows on the graph, then it won't have an absolute maximum minimum depending on the direction of the arrows pointing in. Okay? And they can occur at any point in the graph. Okay, so they could be endpoints or turning points. Okay, and then we talk about relative maximum minimum. Okay, these are relatively high points or relatively low points, but we have to say, I wish they put the word in here, relative turning points, relatively high or low turning points. Okay, they must occur at turning points in the graph, which we just talked about. And they're written usually as an ordered pair, like x comma y. Okay. If the graph has arrows, and this is what I was talking about before, if the graph has arrows indicating it's heading towards positive or negative infinity, then there would be no max or min depending on which way the arrow is headed. Okay. All right, so let's take a look at the first one. Number 2, it says, given the graphs below, find the domain. Okay, so our domain, if you guys remember, we like to put up those nice boundary lines to help it a little bit easier to find. So that's negative 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is at negative 10. And then it goes all the way to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, positive 10. All right, that negative 10 has an open circle, so we're going to do a round parenthesis, but the positive 10 has a closed circle, so we're going to do an including bracket. Okay. All right, the range. That's the lowest boundary, and then this would be our highest boundary. Okay, so we got 1, 2, 3, 4, 5. So this is at negative 5. 1, 2, 3, 4, 5, 6. Okay, and so we would say negative 5, comma 6. Negative 5 looks like a closed dot, so we're going to give them a square bracket. Positive 6, also closed dot, so bracket. Okay, now let's talk about our increasing and our decreasing. So as we read the graph from left to right, we are going to be going down until there, then up until there, then down until there, then up until there, and then down. Whew, so we got a lot of intervals to write. Here we go. Okay, so we are increasing. Let's see, that's negative 1, 2, 3. So this is negative 3. And we stop our increasing at an x value of 1. Again, no need to think about it. Always round with increasing, decreasing. However, I have another red part of my graph, so I got to go ahead and state that. So that's what? 1, 2. This is at 3. When we start our increasing, and then we increase through 4, through 5, and that looks like that's going to be a 6. 4, 5, 6. Yep. Always good to double check your counting. Okay? Again, always round. Okay, the decreasing happened at negative 10. And then we decrease until negative 3. So from negative 10 to negative 3 was that first blue part of the graph. Again, always round. The next part that's blue looks like it's decreasing from 1 to 3. And I have one more section of that's decreasing, and that's happening from 6 to 10. And that part's finished. Okay. Now they're talking about relative mins and relative maxes. Okay. So we'll do those in yellow maybe. So a relatively low turning point is here, and it's also here. Okay. This is not a turning point. That is not a turning point. Those are end points. Okay. We don't know if the graph past those points is going up still or if it's turning and going down because the graph ends there and doesn't really end there. It keeps going, but we don't know what our picture ends there. So I don't know what's going on there. Okay. But those would be my relatively low turning points. And so when they ask for a relative min, they're asking for the coordinates of it. And so we can go ahead and say that this first point here in quadrant 3 would be -1, -3, comma, -2. But then I had another one in quadrant 4, and that one is at +3, -1, 2, 3, 4, -4. And their coordinates, and that's why they're getting round parentheses. So super confusing with the round parentheses, but if you're stating a coordinate, coordinates always have round parentheses. Okay. All right, we're going to go to the top of our graph and see if we can find some relative maximums. Okay, so we're looking for turning points, and we have 2 of them. And this one is relatively high or a relative max, and so is this one. Okay, so those are my 2 turning points that are relative maxes. And so again, we're going to state the coordinates of the first one. So that's what 1, 1, 2, 3, 1, 3. And I guess we could put commas in between them, or we could put an and symbol, doesn't matter. Okay. This other one is at 6, comma, 1, 2, 3, 4, 5, 6. 6, 6 is the coordinates of that relative maximum. Okay. All right. So then the next part says minimum and maximum. It could also say absolute minimum or absolute maximum. Or they could just say maximum minimum. So these are just the absolutely highest y values and absolutely the lowest y values. So because minimum is first, let's go ahead and look at the lowest y value. And this point here is the lowest. Absolutes can be endpoints or turning points. And that's not an arrow. So we can go ahead and say that that absolute minimum is at -5. The absolute highest y value, you can see it up there, is at 6. Okay. So notice this point here was not only a relative maximum, it was also the absolute maximum, and that's okay. Okay, as long as they're turning points. All right, so the next part is it a one-to-one function, and we skipped that lesson, so we're going to skip that question. Okay. All right, let's go ahead and do the next graph. All right, so the first part is talking about domain. And as I go to mark my boundaries, I see an arrow, and I know that it's heading down, but it's also towards the left, so -infinity. And this one, we could go ahead and have a boundary there because there's no points past that. So we're going to go ahead and say our domain is -infinity to 1, 2, 3, 4, 5, 6, 7, 8. And that is a closed circle, so we're going to include that, but the infinities always get round. Okay, so now for the range. And again, be very careful. A lot of people will put their boundary line here, but notice that as that is going down, it's going down, 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 down. So it's not going to have a boundary line there. It's going to actually head towards -infinity. Okay. However, there is no arrow pointing up. And so I'm going to go ahead and say that that is my top boundary line. So my range from the bottom is negative infinity, comma, 1, 2, 3, 4, 5, 6. And we're going to go ahead and include the 6, but not the negative infinity. Okay. All right, so now my highlighter for the increasing, decreasing. As I read my graph from left to right, I will be actually increasing, okay, then decreasing, then increasing, and then decreasing, and then increasing. Okay, so now we're going to go ahead and write our increasing ones, which are done in red. Okay. And that first one looks like it's an x value of 1, 2. Oh, that's an arrow, right? So it's going to keep technically going down, but but as we read it from left to right, we're going up, and so that's why it's called increasing. So you always make sure that you read from left to right. So we're going to go ahead and say negative infinity, okay, is the x value because of the arrow, and it stops increasing at 1, 2, 3, 4, 5, 6, 7. So this is negative 7. And again, always round with increasing, decreasing. Okay, I got 2 more to state. This one looks like it's at 1, 2, 3, 4, 5. This is at negative 5. And that one stops increasing at an x value of 1. Always round. Okay, I have 1 more to state. This one, 2, 3, 4, 5, 6. This is a 6. Okay, to 8. So we got 6 to 8. It's increasing again over those x values. Okay, decreasing. And again, when you put those little numbers on your graph, I think that makes it helpful for the second part. Okay, so this one you can see is negative 7 to negative 5 is that blue part that's going down or decreasing. So we'll say negative 7 to negative 5. And then I have 1 more part. Okay, and again, my little numbers there are going to be helpful. From an x value of 1 to an x value of 6, that is also going down or decreasing. Okay. All right, so now we're on to relative mins, relatively low turning points. So this is a relatively low turning point. And then I have another relatively low turning point over here. Okay, so this one is going to have coordinates, and because they're coordinates, they're going to get round parentheses. So negative 5, comma, 1, 2, 3, 4, 5, 6. This is at negative 6. So negative 5, negative 6 are the coordinates of that relatively low turning point. And then I have 1 more. This one has coordinates of 6, comma, 1, 2, 3, 4, negative 4. Okay. Now we're going to go ahead and do our relative maximum turning points. All right, my son Cameron just came in. If you didn't hear him, he needed his water bottle. All right, so here we go. So relative maximums, we're looking for relatively high turning points. And so we have one right here. We have another one right here. Okay, there's no other turning points on my graph that are relatively high. So I will have 2 relative maxes, and they want the coordinates of them. And so that first one is at negative 7, negative 1. And then the second one is at positive 1, 6. Okay. All right. So let's go ahead and take a look at the absolute maximum and the absolute minimums. So we are looking for the absolute highest point and the absolute lowest point. Okay. Well, if you remember that arrow going down, because it's still going down, it's not going to have an absolutely lowest point. And so we're going to go ahead and say none. Okay. Or you could say NA, non-applicable. Non-applicable. Does not apply to this graph. He does not have a minimum, okay, because of that arrow pointing down. However, he does have an absolutely highest point. And his highest point is right up here. And remember, for maximums, they only want the y value, and the y value is a 6. Okay, and again, we didn't do this last part about 1 to 1, so we're going to go ahead and skip it. And we're going to go and head towards our last picture, okay, or our last graph. All right, here we go. Hopefully they're getting a little bit easier, but they do take some time. Okay, so domain. If I go put up my boundaries, I can't, because as that arrow is going up, it is still going towards the left, so negative infinity. As that arrow is going up, it is still headed towards the right, so positive infinity. And so we could sew negative infinity to positive infinity with round parentheses, or I think you guys are getting better where you can see that it's all going to be all reals. Okay, but either one. All right, your range, the lowest it goes, and there is a lowest. Okay. However, the highest it goes, because of those arrows, we're going to say positive infinity. Okay. So our range goes from -4 on the bottom to positive infinity at the top. Okay. Infinity always gets round, but -4, you actually reached it, so include it. Okay. All right, so I'm going to pull out my highlighters for increasing, decreasing. As I start reading my graph from the left-hand side, I will be going down. So decreasing. Then I'm going to turn and head back up. Okay. And then I will be going back down. And then I will be heading back up. Okay. So we'll do increasing first. Increasing are my red parts of my graph. And it looks like this one is at, looks like it's actually right in between there, which I don't like, but we're going to go ahead and call that -1.5, okay, comma, and it looks like it stops right around 2. Okay, and my second part is going to begin increasing at 4, and then it won't stop increasing, and so we're going to say that that's an x value of infinity. Okay. So for the decreasing parts, we are going to go ahead and say that that's an x value of negative infinity. Even though it's going up, it's still going towards the left, and so we count that as negative infinity. And it stops right where that last one picked up, and so we'll keep that -1.5. And the next one looks like it is starting at 2. When it starts, it's decreasing, and stops at it's decreasing at 4. Okay, and so those are my intervals for increasing and decreasing. Now we're on to relative minimums and relative maximums. So remember that they have to be turning points. And so we have a relatively low turning point here and a relatively low turning point there. And so that first turning point is going to have coordinates of -1.5, comma, -4. The other one has coordinates of 4, -1. Okay. Our relative maximums, we have one turning point that's relatively higher than the most, and that coordinate of that point is going to be 2, 0. Okay. All right, so now we are on our absolute max and our absolute min. So the lowest point on this graph has a y value of -4. And our absolute highest, because of the arrows, doesn't have an absolute highest. And so we're going to say none or not applicable. Okay. A lot of people misstate that and say negative or positive infinity. Well, you can't reach infinity. So that's not an absolute maximum y value. Okay, just an idea. And the last one there, we didn't do 1 to 1, and so we'll skip that again. All right, so hopefully that helps with maximums and minimums and relatives and increasing and decreasing and domain and range, but all necessary things when we start reading graphs. Okay, guys, good job, and we'll see you on day 10. We'll practice some more.